We're going to begin problem 2 just like we did problem 1. If we were graphing first semester, we now see a difference in this problem. Now, if you look at this problem, it looks funny in the order that we have it, but keep in mind that this is the same thing as if I asked you guys to graph y equals -2 cosine theta plus 1. I just want to put it in that order for a minute, just so you guys can see the connection with what we just did and this problem here. This now has a d value equal to 1, which means it has a vertical shift of 1 unit. So now our new midline is going to be at 1. We still have that amplitude of 2, but remember that's going to make our highest point now 3, and then our lowest point -1. Now we still are going to see the period of 2 pi. And we still see that we start at the bottom of the graph because remember cosine that's been reflected will still start at the bottom. However, when we go to pi over 2, our first tick mark, we're now going to be at this midline value of 1. When we get to pi, we're now going to be at the maximum. 3 pi over 2, we're back at the midline. And then at 2 pi, we're going to be back at the minimum. Now, keep in mind, we at pi over 2 are not on the x-axis, which means there is going to be an x-intercept value that happens before we hit pi over 2, which is going to take us back to the pole of the graph. If you remember, when we hit this value, whenever it is, this is going to be an r value equal to 0 in our graph, and it's going to take us back to the pole, which is going to be really interesting how this happens. So you're going to see that things are going to be a little different in this graph because we're going to be hitting at the pole, but at different values. So let's talk about what's happening. First, let's go through using different colors like I did the other problem. At 0, we see this value of -1. And then notice at pi over 2, we're going to be at 1. If you fill in the table, you can think about how what we got for -2 cosine theta from this problem. So notice that when we did -2 cosine theta, I got that -1.7. But now from that answer, I want to add 1. So think about the answer we got, -1.7, but adding 1, you're going to see that when we do this, we're getting approximately -0.7. Remember at pi over 4, we had gotten that -√2 or -1.4. So we can take that -1.4 and add 1 to it, and now we're getting -0.4. If you recall, at pi over 3, we got that value of -1. So take that value of -1 and now add 1 to it. Notice this right here is going to be our x-intercept value. It's going to happen at pi over 3. So I'm going to connect this, go concave up like a cup, and then we are going to go and use orange to do this next part. Remember at 2 pi over 3, we had seen the same thing that we had seen at pi over 3, but remember that now that value is positive. So we're going to have this +1 and then +1. We're going to get this value of 2. Remember at 3 pi over 4, we're seeing the same thing at pi over 4, but now it's positive. So we're getting 2.4. At 5 pi over 6, we're now seeing that same thing as pi over 6, but positive, because we're in quadrant 2. And then remember, at pi, we're going to be at the maximum of our graph. Be careful, the maximum is not at 2, it's now at 3, because of this midline value changing. Surprise, surprise, it froze. Let's do it again. This is why these videos are so long, is because I have to keep doing this. All right. And for other reasons, let's be real. All right, let me go back to my orange so I can connect that. Now, remember, as we saw before, from pi over 2 to pi, we're going to see the same thing from pi to 3 pi over 2, but this time you're going to see that the values are going in the opposite order. They're decreasing. So what you can do is you can take the answer that we got at 5 pi over 6, and that's going to be the answer that we see at 7 pi over 6. You could take the answer that we saw at 3 pi over 4, and that's what we're going to see at 5 pi over 4. You can take the answer that we got at 2 pi over 3, and that's what we're going to see now at 4 pi over 3. And then remember, at 3 pi over 2 is when we hit that midline value of 1. And then finally, for the portion that I'll do in green, again, think about what we saw in red. You're going to see those same exact values, but now in the reverse order. So what we're going to see is at 5 pi over 3, what we saw at pi over 3, we're going to see that value of 0. Then we're going to see this negative 0.4, the negative 0.7, and then at 2 pi, come on. I don't know why this is happening. Is this happening to you guys? Is this like a notability thing, or is it just like a me thing? I don't know. At 2 pi, we're going to be at the bottom. So remember that that's going to take us to that value of negative 1. Now, let's go to our colors and let's get this graphed. At 0, we're now going back 1 unit. At pi over 6, and feel free to use highlighter if you have to, because I know that this can be really tricky. So at pi over 6, we would be at negative 0.7. And then the next line down, we're going to be, because remember, we're now looking at this pi over 4. But remember, because the R value is negative, we're going to the opposite side, and we're going to get that negative 0.4. So about right there. And then we are going to see at pi over 3, we're actually back at 0. Okay, because keep in mind, that would be the x-intercept of our graph. And then at pi over 2, this time we're going to be at 1. So we'd be right here. So what's going to happen is when we connect these points, think about this. For the distance from pi over 3 to pi over 2, so pi over 3 to pi over 2, it does become an actual positive value. So think about how from this distance of pi over 3 to pi over 2, which is in between these two right here, we are going to have a positive R value. Oopsies. So it would be something like this. Kind of comes up a little bit over there. Now going to orange, we can see what's going to happen from here. At 2 pi over 3, we're going to 2. So 2 pi over 3 is going to be 2 lines over. We're going to be at 2. And then at 3 pi over 4, we're at 2.4. So 1, 2.4. And then we're at 2.7. And then notice that when we get to pi, we're going to be at 3 units. Whee! I told you, it's like firework fun. This is, I mean, ooh, ah, what are we creating? 7 pi over 6, we're now in the third quadrant. We have positive R values, which is nice. You're actually going to see the symmetry with this point right here. So note that when you come this 2 angles down, you're going to come right here, and it should be symmetric. Actually, let me move that over just so you can see the symmetry a little bit better. Because again, we're seeing symmetry with this x-axis. This point here is going to have this symmetry right here. And then we have the next point over here, which is going to hit there. And then we're going to see that when we get to, so we were at, where was I just at? Right there, 5 pi. No, I'm sorry, I'm over here. 4 pi over 3, I was like, that's not right. And then 3 pi over 2, you're going to see that you're back at 1. So what we're going to see is at 3 pi over 2, we're back at this value of 1. Notice it's not a negative R value. So you're going to go right there and hit that value right there. Almost done. For the finale, the grand finale, notice that we haven't completed one full cycle of this one. So notice the difference here with this one and how it's differing in the look of it. the 5 pi over 3, notice that we're going to be at 0. So when we hit this angle of 5 pi over 3, which would be, normally right here, we're going to be hitting that value of 0. Now keep in mind what happens after 3 pi over 2 to this 5 pi over 3, because this really right here represents 5 pi over 3. Think about how the values for r are positive. So we're going to be coming towards the angles, which would make sense that it would complete it right here. And then after that, we're going to go to that 7 pi over 4, which is going to have a negative 0.4. So keep in mind the middle angle. And again, if you have to use your highlighter, go to the middle. But since the r value is negative, we're going to the opposite side here. And I'm going to get this negative 0.4, which would be right here. Again, note the symmetry with that point right there. And then if you keep going, you're going to see the symmetry continue. Go to the next angle. It would be here. And then go to the next angle. You would be line that up right there at that value of negative 1. Once we connect those, you get the remaining part of this graph. Beautiful. So with this right here, this is no longer called a circle. The French actually named this one, and this is what we call a, let me use black, limacon. Yeah, I said it. It looks like limacon, limacon, and I think there's some type of marking like here. I don't know. I'm just going to go like that, though. You know me. I don't even know English, so let me teach you French. Limacon, and we say it's a limacon with an inner loop. Whenever you are graphing an equation that has a value that we call the a value, and this value is called the b value, whenever you have some a value minus some b value, a value plus some b value, times either the cosine or the sine, this is what creates a limacon. Now, we'll get into these more as you guys explore, but I just want you to note that it still had symmetry with the x-axis, which we call theta equals 0. Because notice that if I were to do a highlight right here, it does cut this into 2 equal pieces. The maximum r value, however, for this one was 3. Think about why. Think for a moment, because I have to do this one more time. That midline of the graph was equal to this value of 1. And think about the maximum up or the maximum down we're going to go depends on what the amplitude of this graph is. So if you take your midline and add that value or subtract that value, that's going to tell you how far out the maximum value would go for this if you think about it. So that's where we're getting this maximum R value of 2 units away from the midline, which is going to take us to, at most, this value of 3 in our R value.